In the last video, we introduced you to the Airbus A220 production facility here in Mirabel in Canada. We talked to some key people at the program and took a look at the final assembly line and more. In case you missed that video, we'll put the link down below in the description. But today, we're going even deeper into this facility. We're going to take you over to the paint shop. We're going to show you the flight testing vehicle and get on board with a test pilot. We're going to take you into the Flight Test Development Center and even check out a new JetBlue aircraft just about ready to fly with the interior complete and learn about what goes into getting these interiors certified, safe, and ready for passengers, not to mention comfortable and pleasant to fly on. So let's get into it. We're headed to the paint shop, which is apparently a very rare treat, reserved only for the greatest VIPs. But it's super exciting actually to go into the paint shop. I rarely get access into something like that, and that's really interesting to see. I don't know what it's going to be like, but yeah, let's check it out.
Well, first, when they bring in the aircraft, it's a green aircraft, so bare metal. First thing we need to do is mask the whole aircraft. All the seals, the latches, anything that either paint or we don't want to get damaged. Afterwards, we sand the aircraft to bring back the adhesion for some parts, because some parts of the aircraft are already like primed, so we need to reactivate that part. Same for the fuselage. Afterwards, we blow the whole aircraft and then we wash it. And afterwards, we put on the Socogel, which is a sort of binder for adhesion. Then we prime the aircraft. Once that's dry, we paint the aircraft. So we put on all the different colors if there's any colors to put on. And afterwards, well, we clear. We're going to put the clear coat on the aircraft. And once the fuselage is done, then we do the wings and the H-tab, because doing all at the same time for us, it's kind of too big of a task. So we split the tasks, and that's the way we do it.
How long does it take from start to finish?
Depending on the companies, because some companies have different liveries, so some are much more time-consuming, complicated because of some decals or tons of colors. We did some aircraft. We did one aircraft in particular that had like almost 21,000 dots, which are all painted, so we need to do a color, we mask it, we do another color, we mask it, so that was long, but usually it's around a 5-day cycle. That's primarily what we used for like the bigger parts, like shooting the fuselage, the wings. This we use for much more little stuff, so putting on smaller colors and everything. Wow. And this is like really fine, so sometimes we need to do some very fine details or stuff like that, so this is what we use. That's basically what we do here.
And you do the winglets separately?
Yes, because of the width. When they built the paint shops here, originally we were manufacturing another model, which was the CRG in the old days of Bombardier. But when they started the program of the 220, originally the CSeries, but the width with the winglets, it doesn't fit. So because of the machines we have and everything, so they need to bring it in without the winglets, so we paint them the same time, but then afterwards it goes on the other side, which then they're assembled there. I can show you the mix room where we prepare the, I like to call the soup. All the stagings here are adaptable. They're on sort of track, so they can move forward and back and up, down. So we're able to do we could do lots of different type of aircraft, depending if they fit in.
Yeah.
So, because you see, this is a 300. We don't have much space in the back. So this is where the magic happens. Every paint shop has its own mix room, so every one of them is individual, independent. So we're able to paint 3 aircraft at a time if we want. So basically, they prepare all the kits what we need for whatever company we do. So we have shakers. We use about 4 different companies of paint. Each company has its own preferred paint, so we go with what they want. Very specific, because since well, most people in aeronautics know, but an aircraft, when it goes up in altitude, it stretches with the pressure and everything. So, and plus you have an aircraft going from taking off in the Bermudas at 35 degrees, and 10 minutes later it's at minus 56 at 35,000. So the paint needs to comply and stretch, and so it's very specific for aircraft applications. 3 spray rooms of around 150 feet-ish of width, almost 50 feet high. The A220 is about the biggest type of aircraft we can do here.
Yeah, so nice to meet you, Nicolas Rank. So I have the pleasure to lead the team of the Flight Test Center. So you are here in the brand new A220 Flight and Integration Test Center. I say brand new because we've just started operating from early 2024. And basically, to make it simple, we have 2 types of tasks, 2 types of missions. The first one is production flight test. So production flight test is about taking each and every aircraft out of the final assembly line that you have seen previously and check that it conforms to the type certificate. So we check that we are reaching the R standards in terms of quality, in terms of safety, to have the best product at the end. So we do it through different levels of testing, going from the first ground check, the first engine runs, then rejetted takeoff, then first flight, and then we go up to the delivery to the customer. So where we will have a customer acceptance flight with the customer to show the aircraft as it is and to have that trust and then deliver it. And then we have a bit of a more specific activity, which is development testing in general, which is we are improving the aircraft to stay on top of our game, I would say, to stay on the best-in-class aircraft. So we are improving it continuously. So we are having a lot of developments, be it to, I would say, fix an in-service issue or to enhance safety or that kind of thing. And each time you do a new development, you need to test what you are developing.
So you see some tests are ongoing now, some certification testing for new features on the next aircraft. As you can see, these rigs, you have kind of a cockpit, let's say, which is not fully representative, but it's enough to test that the real systems are integrated together. So at the back of the cockpit, you see all the different real systems that are in the loop, and that we can test into details, injecting some faults also into the systems to make sure they are robust even to failures or whatever happens. You know? So, as Nicolas said, this is one of the first integration steps we do. Then once we are confident, we can step up into a more complex rig or onto the aircraft once we consider it safe for flight, and we will carry on the full test until certification. So you see there we are simulating a flight and we are testing some test case and recording the potential concern and then investigating what's going on. What you will see there is similar to what you have for a training pilot. But it's also not made to train a pilot, it's really made to develop the systems and to integrate them together. This is the engineering simulator, or eSim. Here you have the control room. So there we see the current configuration of the simulator. So compared to a training simulator, it's not moving, you know, it's a fixed simulator. And also we have the real systems of the aircraft that are in the calculation loop to simulate what the pilot is seeing. So we can really test the real systems. It's been used for the certification of the CSeries initially, the 220. It's really a certification mean where we are onboarding also sometimes the authority to certify that the functions, the behavior of the systems are nominal as expected. The management panel, so we can have different scenarios, different airports, different weather conditions, and then the cockpit is fully representative to the latest version, let's say, with some little particularities, but really the pilot can fly the simulator as if it was a training simulator and testing the systems. You see we are also recording these are video cameras in case we see some behavior that are happening and we want to review the videos.
Yeah. Each testing facility has its purpose, I would say. Depending on what you want to test, you will choose a facility. So for example, here the simulator is very representative, I would say, from a pilot point of view. So if you want to do human factor analysis and so on, it would be something very adapted to that. But then if you want, you will see on the next rig, if you want to have the real equipment of the aircraft, you want to go and deal for a system which is under pressure, hydraulics and those kind of thing that you will use another type of mean.
Also testing on different runways with different lengths, different slopes to test the corner case, let's say, of the 220. So you see, this is really representative because you have the full size of the aircraft, length of the cables, length of the wires, of the piping. Real surface, you will see there you have the left wing. You see this is the back of the plane there. We have the tail on the right and the cockpit on the left. And so we have really the real dimension to make our testing in most realistic conditions possible. Wow. So every program has its Iron Bird, most modern program, let's say. And this is really something we want to have before clearing the first flight, and it's running during 2-3 years before the first flight, doing a lot of endurance testing, a lot of corner case testing to make sure that the aircraft will be safe when you fly it. Yeah, so there you see the left wing of the aircraft, and you can see on it we have some load control system that is loading the slats and the flaps, simulating the aerodynamic forces depending on the flight conditions, and so we can test the actuators with real strengths, real constraints in the system. We also have some engines simulated, so the engine is stimulated with an electrical engine that drives the pumps and the VFG, the variable frequency generator. So the electrical power of the aircraft is generated with the real system for the rest of the aircraft. And there you see one particularity of this Iron Bird is that we have also the cabin systems. So we can test the different customization for the different head-up versions for the different customers. This is a bit particular compared to Airbus traditional Iron Birds, where the cabin is separated from the rest of the aircraft.
We are there to simulate the aerodynamic pressure that you would have on those things in order to make the test the most realistic possible in terms of efforts and moments. So the thing that you would have in the real aircraft, I would say, integrated in the cabin here, all being stripped in order to be able to adjust, to test, and
some panels where you can switch on the lights, this kind of stuff. So not as fancy as a real aircraft, but at least you can test it works correctly. You can see, for example, the actuation systems for the HTP, the horizontal tailplane, and some of the hydraulic systems that powers the actuation. The parts, we have the mass and the size of the physical elements that are representative to really simulate the good forces you have in each actuator, each moving parts.
Amazing, the Iron Bird. It's something I never even knew existed as part of a flight test program. Makes perfect sense. Let me know in the comments if you knew about the Iron Bird and that most aircraft test programs have one.
So yes, here we have the control room of this rig where we can execute the test, monitor the different systems. You also have some instrumentation to monitor, for example, temperature or whatever is required to be sure the test is going safely, let's say. And there you will see the cockpit as well is also fully representative, but we don't have the visual. So like Nicolas said earlier, it's more representative for the physical systems, but in terms of pilot perception, human factors, whatever, it's a bit less representative. So you choose the test you want to do on one bench or the other.
So welcome to the Flight Test Center.
Thank you.
We're going to see one of the two flight test vehicles. In fact, those two aircraft, they were formerly part of the certification test campaign from the CSeries. And now we've flown them from Wichita, Bombardier Flight Test Center, to here in Mirabel, beginning of this year. And now we're using them on our development activities. So one is currently on a test campaign, and the other one is the one that you will see that Marco will show you.
Second ever built CSeries or A220. and it was used extensively for system testing.
Yeah.
And to support some of the handling qualities and IC campaign and so forth. So spend a lot of time on the airplane. It's a second 100 model.
Yeah.
The other one, FTV7, is actually 300 model, so it's away on test campaign. But this one pretty much has everything inside as the 300, as the bigger brother, and I'm sure you'll be impressed with what you see in there. So this is a flight test dome where we keep one of the FTVs. That is FTV2, or black sheep, how we used to call it. It used to be painted in black nacelles and just primer for the early life, and now it's actually repainted in Airbus colors. So as you see, sorry about the dark, everything is orange inside, and that's typical flight test color. So everything orange doesn't belong to the normal airplane. It's a flight test installation. You'll see that the cockpit currently being serviced with the AFD4, but it has some very unique features on there. Observer seat, some emergency equipment. This is a flight test egress system. This is actually used for bailing out of the airplane. We can actually jump out of the airplane in case of emergency. We have two, aft and front. We actually go through the cargo door of the airplane. These are FTE stations. This is where typically avionics or secondary FTE sits, or trainee, if you will, if we are checking them out. And this is a primary FTE station, basically where FTE conducts testing from here and directs the test with the crew. We have obviously water ballast throughout the airplane. This is to simulate the passenger load. We don't want to fly with passengers or people, so we load the airplane up with water. And we have movable ballast, which means we can actually transfer water from back and forth and simulate the CG shifts in flight. We typically take the engine parameters. This is a so-called Pratt & Whitney station in the back, and another secondary FTE station in the back. You see the trailing cone capstan, which is the wheel that has a very long hose, basically, that extends from the tip of the V-stab, and we use that for all kinds of measurements, including airspeed and altitude. So that's the aft egress, various depress windows. Everything is sequenced such that if you have to get out at high altitude, you can actually depress the aircraft in sequence with deployment of the egress system and so forth. So sometimes, yes, we fly with parachutes and helmets and oxygen masks and so forth. I was part of the original Ship 1, FTV1 crew, but as FTV2 was coming a couple of months down the road later on, and after we had some issues with the FTV1 and engine, and aircraft was grounded for a while, we actually took over this one and continued the flight test campaign with the original FTV1 plan until it got fixed. So yeah, I'm intimately familiar with this airplane. Probably have about 300 hours on it. There's a typical stereotype about flight test and, you know, stepping into the unknown and so forth. At this day and age, we can certainly simulate the aircraft well in advance before the first flight. So we actually flew this airplane almost 2 years before it actually went for the first flight in the simulator. We pretty much learned all that could have been learned like that. So it was predictable, it was safe. Of course, all the risk management was in place for the unexpected and unknown situations, but aircraft development in 2000s and 2020s is way different than in 1960s. So
so not very many surprises once you actually take it in the air.
No, we have a saying that if you get excited, you're probably doing something wrong. But yeah, I mean, obviously certain events and certain tests are very dynamic, and you don't get to see them in service, like empty dive, like natural stall of the big airplane for the stalling characteristics and so forth, which is probably something that this aircraft will never see in service ever. So those were very interesting and really nice experience to go through. But once you get and step behind the envelope expansion, the handling qualities expansion of the aircraft, and then it's a little bit smoother sailing after that. So.
The section of panel here that's orange.
Yes.
That's specifically
there is a flight test installation for sure. So there are various, we can obviously change those panels, but there are various systems that are being activated, flight test systems, at crew discretion, basically as required by the test. So we can have all kinds of fuel shut-off valves, hydraulic shut-off valves. We can actually actuate the egress system from there or any other station. We can actuate the fire bane system, which is another very cool feature that was introduced to the flight test vehicle mid-campaign as a risk mitigation for any kind of crash on the runway. Those barrels there behind us, that's a fire bane gel agent, and you see the nozzles all over here. It can get actuated automatically, and this is the firebrand trigger, or crew can actuate it. And basically what it does, it coats every crew member in a fire retardant gel, and it gives you about 15 minutes of survivability under heat if we were to crash on runway during the runway performance testing or so forth, so that we can actually have time to get out.
Wow. Seen so much today already. Now it's time for another exciting thing, to go inside one of the customer aircraft that's just about ready to deliver, and we're going to check out what the cabin is like. Actually, this one I've never been inside out there in the world. I've never flown this one, and there's quite a few out there flying around the US now, so let's check it out. And we're on board the JetBlue A220. I've flown JetBlue pretty recently, but I haven't been on their A220. I haven't been inside it at all, and I haven't flown on it. It seems like it would be a great ride in here, especially in these even more space seats, which you can see by the orange leather on the accents on the seats. But even in the regular seats, it's such a comfortable configuration, and just having that 2x3 layout, the seating layout, I mean, the difference in comfort with the two seats on one side, if you can get over there, obviously. If you're solo or with someone else, even better. It's just fantastic, and the legroom just looks enormous in these seats. I'm gonna try it out. Even back here, so much legroom. Wow. Not to mention the seat back screens in every seat, which is definitely very rare in Europe, and even in the US these days, not necessarily a given. It's just very premium, very deluxe. And look at this legroom in the even more space section. Seriously, give me that any day. On a transcontinental flight, fine, I don't need business class.
So welcome to the A220 for JetBlue. I think 140 passenger. This is a really wide aisle, around 19 to 20 inches. And one interesting fact of it's not only this airplane, but it's all the airplane of A220. This middle seat here is 1 inch larger than these seats. So it's even some at the beginning, some airlines were selling it as a premium seat because you're wider. So if you travel on A220, it's good to know that you'll have 1 inch more space in the middle seat. So I'm the head of interior engineering. My name is Jocelyn Gariepi. About 165 people in my team does the integration and the certification and the design of everything you can see and touch and maybe don't touch in this airplane, including things you don't see, which is the Wi-Fi. So this airplane has Wi-Fi, the in-flight entertainment that are in the seats, the cabin management system that enables the flight attendant to work on the cabin. They can even from that cabin management system, if somebody is asleep and the reading light is open, they can close it from there. They also adapt the mood lighting. In my team, probably I said 165, probably 70 engineers in my team are in charge of the certification for flammability. So every part here has passed
the flammability test. Sometimes we recertify through similarity, but when we have new component, new sandwich, even the floor covering, even the carpet got tested. Occupant safety. So occupant safety, if it's for all the rules pertaining to the flight attendant in the emergency. For example, here, if you would have an emergency equipment bottle, there's a regulation that the flight attendant need to reach it within 5 seconds. So this team is in charge for the location, and we verify that through testing to make sure that when the for example all the placards are all visible, we make sure the field of view. And the other team for certification is stress. So all the components need to pass a 9G or 16G dynamic for the seats. So we are doing testing. My team witnessed some testing with crash test dummies, to make sure that these seats can sustain 16G, or the passenger can sustain 16G without having a concussion. So there is we call that the IC value. It needs to be below 1000 when the dummy, that's an instrumented dummy, when it hits the screen or the back. So this is all tested for a front row collision and a side row collision.
Wow.
There's a lot of regulation. For example, this latch here, the catch portion, is double to make sure that if there's a crack in one, well, the other one will function. So this is part of the redundancy in aerospace. So even in the bin.
Little known fact that there's redundancies in there.
We are currently working in changing these bins. There will be XL bin, we call it. This is our brand name. It got launched last year in 2023, but we are finalizing the design. The design is frozen, and now we are manufacturing the tooling with our subcontractor, and we're going to perform the testing, the static testing, the flammability testing, and also the certification for the electrical harnesses that pass through that. This seat needs to pivot to go into the aisle when the flight attendant is during takeoff and landing. They need to see a certain percentage of the passenger and the front flight attendant also, to make sure everybody is safe and secure while landing. There's also design for example, here that handle, this is an assist space. So the flight attendant there's a regulation, needs to have that space in case of evacuation. So this is all also controlled. This curtain is controlled versus these signs to make sure they are readable. So there's a lot of rules. For example, this thing needs to retract to make sure in case of emergency it doesn't block, because this is either this side and this side will be an escape route.
Of course.
In here you have the bustle, there's a slide.
They're simple things, but they're insights that you never get.
Yes. Well, they are common sense, and sometimes they get developed based on events that occurred either during training, or the regulation gets corrected and adapted for these things. Here you have a horn. Cool. In case, because this is also, it's the last resort in case of evacuation. You use that horn. But usually, if this is functioning, they will use the PA. So this is a fire extinguisher and oxygen bottles, and also with the emergency medical kit. And those, I was referring to those, there's a need for a 5-second access. And not only for the average flight attendant, we need to have a 5-second access for the 95th percentile and the 5th percentile. So we also validate that. So you could imagine the location matters, because for a 5th percentile, less reach. And sometimes for a 95th percentile, when you install emergency equipment like this, well, you need to go down. It is harder for them. So we need to validate that.
So the percentile is in terms of height.
Yes.
Yeah.
In terms of height. There's also a requirement for the headset that the 5th percentile and the 95th percentile is able to reach the headset while takeoff and landing. So which is with the 3-point buckle seat belt. So that's also a requirement. And at the one that I was pointing at the back, it's a bit harder because you can tell it's a bit higher. So we had when we designed the other seat, we had a little challenge, but we made it pass eventually.
Wow. And you were saying this sort of rounded edge is particularly good.
Yes, this particular design it was done for JetBlue first. Philippe and my team, in my designer team, are quite proud that we were able to achieve that with the nice integration of the console for the front displays.
Yeah.
Before going to the cockpit, we have lave. This is every A220 has this lave, and as you can tell, even if it's a single aisle, this lave is quite spacious. It's almost a first-class lave. Part of this lab is also because the cockpit door, as you know, since 9/11, the cockpit door is reinforced, lots of regulation. So also the wall of the lab is reinforced, and the wall of the G1 is reinforced. But when the cabin gets delivered into the airplane, the wall is not there. So it's the interior monuments that does the wall. This is a complete tube. I don't know. You probably saw it through your visit. So part of the cockpit, also the third seat, is an interior responsibility, along with with emergency equipment at the back.
All right, so you're taking care of this.
Yes.
But not this.
No, this is where the responsibility of my team ends. This is the team of cockpit that does the integration of that portion. So when the cockpit portion, the structure and the interior gets delivered, it's already stuffed, and this is the responsibility of my colleagues at Stelia. I was heading the map team, which is the people that help from engineering that help the aircraft delivery at the really beginning of the program, when we were first delivering to Swiss. So at the beginning it was more difficult to deliver, so it was really important. We had some snags, and me and the production director, we were watching on flight radar our airplane. Okay, they're doing the full run, the full flight test, so they must have resolved our issue on the flight test plan. So we are even using this to follow our plane. So we're using the flight radar app.
All right, what a great opportunity this was, and what a cool chance to go around here at Mirabel at the Airbus facilities and get a look inside so many different aspects of how the A220 is put together, literally assembled, also tested, developed, everything. And so cool that it was all within kind of easy walking distance, where you have everything going on, so much of the process here where the A220 was born years ago. 6 years it's been part of Airbus, and seems like a really nice kind of turning point now, where they're beginning to ramp things up production-wise and looking to ambitious goals ahead. The future is bright for the A220. Quite a few aircraft, hundreds of aircraft on order that have yet to be delivered. And, personally just love flying on that aircraft, so it's so nice to know that they're cranking them out, and will be doing so even faster in the years ahead, so that we can have more A220s around to fly on out in the world there. So only a shame that I'm not flying an A220 later tonight, but I'm headed to Mobile, Alabama to see the other side of this. That's where the other final assembly line of the A220 is, and we'll see some other stuff there as well, including A320 production. So that should be really interesting. My first time in Alabama, actually, and another really interesting insight into the North American operations of Airbus. So make sure you're staying tuned for those, and much more to come. Thanks for coming along today and joining me on this really nice visit here in Canada for Flight Radar 24. I'm Gabriel Lee.